All right, let's go over quiz 3. Quiz 3 is over exponentials and recursion. So this is quiz 3. Let's start with number 1. So some of the problems from quiz 3 are from quiz 2, just a requiz over that. So on this one it says graph y is equal to 2 to the x. Okay, so this is graphing an exponential function with a base of 2. So we do know that an exponential contains these anchor points, these special points. Whenever I plug in a 0 right here, 2 to the 0 gives me a 1. Anything to the 0 gives me a 1. If I plug in a 1, 2 to the 1 gives me a 2. So right here is actually going to be the base. So 0, 1, 1 and the base. So this is going to be 1 and 2. So this is going to be 0, 1, 1 and 2, which is the base. If I plug in the negative 1, this is going to be 1 over the base, right? Negative exponent right here just flips the base. Instead of 2 is 1/2. So it's going to be like this. Oops. Let me do that better. Like that. Okay. So we know that there's going to be an asymptote right here. And that's it. That's the graph for that one. Let's look at number 2. Number 2 says if the graph from 1 is changed to y is equal to negative 2x, what is the transformation? So in case you forgot, this is the function from number 1. Y is equal to 2 to the x. So the difference, all it is that it has a negative out in the front. So we should know that this is 2 to the x looks something like this, right? 2 to the x, well, like that. This negative to the x, what's going to happen is actually going to flip. And how do we call that? This is called reflection, reflect over x-axis. Okay, and that's all. So again, so now, and just in case you're not sure, we can just do it both on a calculator. This one is going to be 2 to the x power, and the second one is going to be negative 2 to the x power. So let's see what happens. This is 2 to the x, the original one, and this is negative 2 to the x. So you see, you just reflected over the x-axis. What is the domain and range of the new function? So the new function is, well, let's see, the domain again is all the x's. You see that this is going to go on forever that way, is going to go forever that way. So it covers all the x's. The domain is all the reals, all real numbers. What about the range? The range is going to be all the y's, right? The y's that are present. Well, there's nothing up here. Okay, there's no function up here. I'm looking at the blue one now. The function only exists from here down, right? How do we write that? The range is going to be all the y's that are below the x-axis. So that is all the y's less than 0. Okay. Number 3, it says write a model to calculate the balance of a savings account with an interest rate growth of 2% compounding yearly after X years. The initial deposit is $4,200. Hint, use y is equal to a 1 plus k to the x power. So it already kind of sets it up for you. This is exponential growth. So all we're going to do is we're going to just plug in all the numbers. All it wants is the model. Yes, after X years. So it doesn't tell me to plug anything in to see the result. We're just going to look for the model, which is the equation we're going to use. Y is the output, so it's going to be y is equal to a. A is what? A is the initial value. What is the initial value of the bank account? This is the initial value, so this is going to be my a. 4,200, so this is a right here, 4,200. 1 plus k, 1 plus k is the rate of growth or decay. In this case, it has a growth of 2%, so it's going to be a positive k. 2% is 0.02 to the x power, so another way to write this down is 4,200 times 1.02 when you combine these two to the x power. That is the model that I would use to calculate the exponential growth of this situation. Let's look at number 4. It says the flu virus has spread through Pasadena High School. Fortunately, many got the vaccine at the beginning of winter. If X is the days, the number of those infected with the virus is modeled by this equation. So the model is already given to you. The model, again, being what equation do I use to use my inputs and see the result. How much time until only 60 people have the flu? Okay, so how much time until only 60 people have the flu? So 60 is going to be what? What input is this? Is that going to be N or X? 60 is actually going to be here. It's going to be the number of people. X is always the time. X is the time. So this is not time. This is the output. So the way we're going to set this up is we're going to put 60 in here for N. 60 is equal to 120 times 0.75 X over 12. Now I'm going to do it two ways. I'm going to do it the way we're supposed, the right way to do it. Let's say if these A, B, C, and D were not present. So we're going to do it like that the first time. And if you skip a little bit ahead, I'm also going to do it the easy way, or the other way, I guess you could say. Another way, so where you can just check your work or double check your answer. So right here, again, we have an exponential function. So I want X by itself. So I'm going to use algebra to get X by itself. I have to get rid of all the other numbers. So let's begin with the 120. How do I get rid of the 120? Well, this is 120 times all that. So what I'm actually going to do is I'm actually going to divide both sides by 120. 120. So right here, these 120s are going to cancel out. 60 over 120 is actually 1/2. So this is going to be 0.5 is equal to 0.75 to the X to the 12. X over 12. So again, I want to get to X by itself. So right here, I want to kind of break this apart. I want the X by itself. I want to break this base and this exponent. So we have a new tool, which is logs. We can use regular log or natural log. Since we're more familiar with logs, let's just use regular logs. So what we're going to do is we're going to get the log of both sides. This is going to be log of 0.5. So let me rewrite that. I'm going to get the log of the left side and then the log of the right side. So log of 0.5, we're going to find it in the calculator right now. Well, actually, let's do it like this. Right here, we're going to use the rule that if we have an exponent, we can bring this to the front. So we can rewrite this as use a different color. This is going to be X over 12 times log of 0.75. And then over here we have log of 0.5. So we can imagine the parentheses over here. If I want X over 12 by itself, I can actually divide both sides by log of 0.75, log of 0.75 over log of 0.75. So let's see what that is. Log of 0.5 divided by log of 0.75. So it's going to be log of 0.5 equals divided by log of 0.75. 2.41. Let's say 2.41. So we'll bring all my work over here to this side. So this is going to be 2.41 is equal to, so remember, we divided by log of 0.75. So these actually cancel out, and all I have is X over 12. X over 12. X over 12. Now, how do I get rid of the 12? I have to multiply both sides by 12. So pretty much the last answer, multiply times 12. Times 12. Answer times 12. And I have 28.9 which is, this is the closest answer, right? So x is equal to 28.9, and that is 29. Now there is an easier way to do this. Since we do have options, we have answer choices, we can actually just use the answer choices to our advantage. These are all these answer choices are the days, how long it would take for me to get 60 people with the flu. Okay, so this is going to be 60, right? These are all possibilities for x. So that means that I can just plug in one by one into x. Since we already know that the answer is 29, I'm going to show you how to do that. We're going to plug in 29. So we're going to plug in 29 into 120 times 0.75 raised to that power, and we should get 60. So let's see if that happens. So actually, so this is 120 times 0.75 raised to the, I'm actually going to put this in parentheses since it's a fraction. I'm going to put 29 divided by 12. It's going to be 59.8. I want to know how many people. I was looking for 60, right? So this is going to be the closest one from all the choices that we have. So here the answer again, it's B. Let's see if we can finish this here. Number 5, right here we have an exponential equation solving with exponentials. So right here I have 2 to the 4x is equal to 4 to the x plus 5. So we're going to use a property that says if we have something like, let's say if this problem said 2 to the x is equal to 2 to the third. We know that since everything else matches, x has to equal to 3, right? Because the bases are equal. These bases are not equal, so we're going to see if we can make them equal. 4 is actually just what? 4 is just 2 to the second power, so I'm going to rewrite this 4 as 2 to the second power. So this is 4, right, to the x plus 5, and this is equal to 2 to the 4x. So now you see how the bases are equal. This tells me that we can use this property right here, and so 4x is equal to this. Well, what is this? The rule right here is a power raised to another power. All it's going to be is these powers multiplied. So this is going to be 4 to the x on the left is equal to 2 times x, which is 2x, and then 2 times 5, which is plus 10. If we move the 2x over here, that's going to be minus 2x. 4x minus 2x is just 2x. It is equal to 10. Divide both sides by 2. X is equal to 5.